Go ahead and hit record on that. So introduction to NAT and PAT. Our outline will be talk about network addressing. How does two computers talk to each other on the network? LAN IP addresses, local network IP addresses, WAN IP addresses, wide area or a router-to-router connection, IP addressing, and then outgoing internet access, how NAT and PAT plays into that, and incoming remote access and how NAT and PAT plays into that. All right, so there's our outline. Let's go ahead and get started. I don't know what level of students we've got in here right now. So we always start off with the basic, which is, as I've said it in many lectures and many times, is that I always compare IP addressings of two computers talking to each other as a telephone conversation. In a telephone conversation, when person A wants to call person B, person A needs a phone number of, let's say, 214-123-4567, right? And then person B over here would we need a phone number of what? First part should be what? 214, and then the famous number of 555-5555. All right, so now that they both got a phone number, the first section means what? What does this section mean right here? Area code, right? Area code, which for us would translate to networking. So this would be who we are, because we are both in what area code? We're both in Dallas. That's what the 214 means. That means that you're both in Dallas. You're both in the same local area. And to call locally, not long distance, but locally, you have to have the same area code so that y'all can be on a local network. So what is the second portion right here? That's your number. That's you on this network. So this would be the me portion. Can another person have this section right here? They can if they have a different area code, right? So, but not in the same area code, they can't have the same phone number. Two people can't have the same phone number, and it works the same way. So over here, this is the me portion. The red can be considered the us portion. This is us. And for us to be considered in the same local network, we have to have the same area code. And then the second portion just identifies me in this area. Okay, so this translates the same in computer communication. The first part, I'm going to give this computer a random IP address of 192.168.1.1. Computer-to-computer communication works the same way. There needs to be an us section or a local network section, and then there needs to be a me section. The thing with IP addressing, though, is that there's another IP address that decides which portion is network and which portion is the me address. Okay? So from now on, instead of calling this the area code, we'll call this network. And we'll call the blue section what? Host. Okay? All right, so down here, the subnet mask, which is the bottom part, this is the IP address. The subnet mask will identify which part of this is network and which part of this is host. And the subnet mask works in a very simple way. There's only two, as of right now, there's only two options we can put. We can either put a 0 or we can put a 255. Now later on, we'll tell you to forget this in subnetting and we'll learn how to change those numbers. But as of right now, a 0 means the host, or the me. This says host, doesn't it? The 0 means the host, which is the me portion, right up here. And then the red would be the network. All right? So down here, I'm going to decide to put a subnet mask of 255. 255.0. Now by having this, since the 255 means network, so I'm telling this IP address on top that this is part of your network, and then this is the part of your host. Everybody with me so far? Okay? So, how does that translate to so that this computer can be on the same local network? He needs to have the same area code or the same network portion, which would be 168.1, which means he's going to have a subnet mask of 255, 255, 255.0. So what is this last portion going to be right down here? 2. It can be 2. It could be anything within the range of 1 through 254. Technically, it's 0 through 255, but we can't use the first and we can't use the last. So 1 through 254 will work. Now, the other exception is that it can't be 1 because he is 1 down here. Right? And just like you can't have the same phone number, you can't have the same me portion in your local network. Correct? Any questions there? No? Some of you look at me like, yeah, we've seen this before. All right, so moving on. LAN addresses, local network addresses. And through your tech labs, you've been working a lot with local networks, especially with the virtuals where you set up a couple computers to talk to each other and they're not connected to the internet, right? All right, so in this little scenario here, how would a LAN address work? I need 3 things for each computer. I need an IP, a subnet mask, and a default gateway. So who wants to give me an IP address? You want to give me an IP address? 19. Oh, okay, sorry. Let me start over. All right. 192. 72. All right. Next, subnet mask.
Let's do 255.255.0.
So you're playing something funny here, right? Yeah. So you switched this Class C address to a Class B, but that's okay. So next, somebody else want to move on to the next computer? Nobody? Lots of great volunteers around here, let me tell you. Isn't it? I need to give you a sugar next time. All right, computer 2, Billy?
192.72.1.164.
All right, next. Mai, what's the subnet mask here?
255.255.0.
Okay. Chris, who's my IP address for my top?
192.72.1.1.
Okay. Who hasn't given me something? Bertha! She's like hiding back there.
255.255.0.
All right. What's that?
I said she's got a deck more.
She got Doug Moore. All right. So who's my default gateway for this guy? The router. In local area networks like this, your router will always be your default gateway. Okay, whatever his IP address, which he is who? He is .1.1, that is who he is. He will be your default gateway. Okay? So 192.72.1.1, that's it. Sorry. So that makes him into the default gateway. What does the default gateway mean? Anybody? What's the purpose of this guy? What's that? Way to get to the internet. Plain and simple terms, that's all it means. So if you weren't connected to the internet, did you need a default gateway? No, not really. Not your subnet. Another thing is if a packet doesn't know where to go, If he doesn't find nobody on your network, he just sends it on to the default gateway and let him take care of it. Okay. All right. So who's his default gateway? Same guy. .72.1.1. And who's his default gateway? Your ISP. That's right. I thought I was going to trick you on that one. But in this case, we can go to our ISP. So let's go ahead and talk about ISP and WAN addresses. Okay. Has anyone ever gotten internet and just had one computer in their home and that's it? Just one computer? No? Okay, I have. I had one. You have two? Okay. Yeah, way back in the day. Okay. Don't spoil my bubble, Chris. Okay, so when you have just one computer, okay, it could be a nice computer. It doesn't have to be one bad computer. It could be a nice computer. If you only have one computer that you need to physically connect to the internet, you call your ISP, and who would be an ISP? Oh, what the heck? There it is. So who would be an ISP? Verizon. So you're going to call Verizon. What? Everyone has Verizon around here. Okay. No? We have some anti-Verizon. All right, so Verizon can come by. They're going to hook up your 56K modem. No? Your DSL? Okay, we'll go with DSL. We won't go over with Fios. No Fios, not yet. All right, so they're going to hook up your DSL, and what are they going to drop off? What is this device right here? This is a modem. It's a surfboard. What's that? Well, if it's Fios, it works. So. All right, so this is the Motorola surfboard. So it's just a modem, total modem. All right, so in their modem, they have an IP address that connects them to their local network. Okay, they've got a network of themselves, which comes out and probably connects to everybody on your street that is connected to Verizon, and you need a connection to that. So their local network, which would be some weird address, probably like 66.11.12.13, and a weird subnet mask, which we won't get into subnetting yet. So we'll just skip the subnet mask. 12.13. So they've got their internal IP for their internal network there. Their network is connected to other networks, which allows you to talk to other servers and other websites and so on. All right. So this is for you known as your external IP. Okay. This is the IP that connects you off into the world, and the world being the Verizon network. But the Verizon network happens to be connected to all the other networks that are known to each other, and it's a big old web. I know we call it the cloud nowadays, but we can still call it the web. All right. It's also known as your WAN IP address. Now that's in your modem. Then all your modem does, it gives you a gateway. We'll go with black. It gives you a gateway to the internet, and that's it. So your computer here will get a direct connection to the modem, and off to the world it goes. Right? Anybody ever had that? Just one computer. All right, so what happens if you have more than one computer? And everybody here would probably say, I've got more than one computer. Right? You need a router. So now, let's put the two together. Now this right here looks like your local network, right, that we had earlier? And then here's the external network. So all we did was plug in our router to the modem. In the back of the router, there's several ports. There's a port by itself. It actually says internet on top, or sometimes says WAN. And then the rest of them say LAN, or sometimes say computer. So in this case, with the one that's separated, would go to our modem, and then the other four are used for our local computers. All right, so does your modem still have your external IP address? Yes? Now, are you getting a just straight gateway now? You are. Your router is now the one that has access to the internet. Okay, you still only have one device on the internet. Okay, but in this case, it's no longer your computer. The one device on the internet would be your router. Okay, so now your router has a default gateway to reach to the internet. Okay, so let's put in an IP address for them. And I'm going to go back to standard Class C address so that we don't confuse anybody. Okay? With a subnet mask of okay? So now the only one that has internet connection would be your router right here. He has the default gateway to go to off to the Verizon network or to the internet or to whoever. All right, now down here, we still need our local network connection, which let's give him an IP address. Somebody? 192.168.1.5. And then over here, no, let's go higher. Let's go higher. Oh, I like that one. Oh, we're missing an octet there, aren't we? I'm going to blame it on Bertha. Oh, Daryl's here, right? No. Oh, Daryl, by the way, I was at Chris's house, and I think we messed something up. And I said, darn you, Daryl. And you weren't there, but it was still your fault. Just so you know. No, he let me in his garage. He wouldn't let me in his house. All right. That is one house you don't want to go into. He's got all sorts of defense mechanisms. All right. So back to, I'm going to cut that out of the video, by the way. Okay? So back to our local, back to our internal network here. We've got our local computers talking to each other. Now, because they are in the local network, and that's what this blue line right here identifies as your local network talking to itself. I can send packets from here to there, and from here to there, and from here to here, and from here to there, and so on and so forth. And the router can talk to the world. But right as of the way it sits right now, without NAT and PAT, they cannot talk to the world. Why not? Because your ISP only allows one device to connect to the internet, which is this guy right here. Okay? Unless you pay them more, they won't give you another external IP, because this external IP is the phone number that people reach that router. Okay? So your internet service provider only allows one device, which in this case would be your router. Okay? You can put your computer, but then if you have more than one computer, you can't connect anyone with the other computer. But in this case, your router is the only one who can access the internet. And that is where NAT and PAT comes in. The way this system works, and well, first before I go into that, the reason it came about is because we started running out of these IP addresses, right? They're like, oh no, we're running out of IP addresses. Everybody wants to be on the internet. Let's find a way to save some. And then they started working on subnetting, and then they started working on IPv6. And then right in the middle of all that, somebody came up with NAT. They're like, well, there's a technology we can use that will allow us to let this device funnel everyone's traffic through their single IP connection. And that's the NAT and PAT. Okay, and there's different versions and so on, and we can get into that a little later. And the book's going to tell you about all the different NATs, one-to-one, NAT overload, and so on. But right now, it's just kind of like the introduction of how NAT works. All right. So another thing that I've said before, and I always bring it up, is that a connection, every single TCP/IP connection is a freeway, right? A freeway with plenty of lanes. And if anybody ever heard me say this before, what are those lanes? Ports. Okay, port numbers. So every single one of these is a freeway that has a lot of lanes. And these lanes, we're going to call them ports. Now, these lanes are numbered from 1 and up, and they keep going. And there's certain lanes that are specifically used for certain traffic. Just like our freeways, you know, the shoulders you're not supposed to drive on unless you've got a flat tire, or the police or the ambulance or somebody, they can drive on it. The same thing is going on with this, except for that a lot of the lanes are reserved. For instance, there's a lane, number 21, that's reserved for what? Anybody know? FTP. Okay, FTP is a type of network traffic that will allow large files to come in and go out, right? So this lane or this port number 21, or lane number 21, port number 21 is specifically dedicated for FTP traffic, and that's it, okay? And there's a lot of them that are dedicated. So port number 110 is for POP email. Port number 43 is for SFTP, right? I'm sorry?
Which one?
443. Yeah.
443 is for HTTPS.
443 is for HTTPS. 80 is for what? HTTP. What is HTTP? The World Wide Web. We're going to talk a lot about that one. We'll put that one over here on the side. 80.
I think that the IANA is pretty much for the ports 1 through 1,000 roughly, or the well-known ports they call them.
Correct. And if you ever want to know like the whole list of well-known port numbers, you can always just go to Wiki or somebody or just Google it, and it'll be a long, super long list of traffic that you probably never even heard of. Okay. Now, the other thing about this freeway, does anybody remember how big this freeway is? There's 65,534 or some say or so lanes. So there's 65,000 ports in each one of these connections, right? So it isn't one freeway that everybody uses. There's 65,000 ports there, 65,000 ports here, 65,000 ports between every single network connection, okay? Because those ports are there. So in overview, what they found out is like, hey, we know we've got the first 1,000 or so ports already full and dedicated for certain type of traffic. But what if we use all these empty ports, some of these 65,000 ports empty, to funnel all this through the internet? There's only one problem, is that we said that all traffic for the web, for websites, run on port 80, right? So from here to there, right, this connection here, port 80, is specifically for websites, which in our world today, websites are like the number one thing we use internet for. Some of us IT people will use it for remote connection, or internet access for remote connection, for FTP traffic, for email and so on. But the majority, the meat and potatoes of it all, almost everything's on port 80 or 443, which is the secured. So what they said was, well, let's find a way that this router be a little bit smarter in order for it to funnel all this traffic through that one single connection. So what it does, it creates a table over here. For instance, I'm going to give you a scenario now. Let's say that this computer here opened up Internet Explorer. Okay? Internet Explorer is a browser, a web browser, and he went to google.com, and he's waiting for the page to download that has the little picture of the Google, and every day he goes and he tries to figure out what kind of picture they got today. So he opens up his computer, types in google.com. What the computer does is he's going, remember right now we're talking about outgoing, this is how we access the internet. What he does is he sends a packet to the router saying, hey, I need to get to google.com. And then there's a whole DNS part where the router will figure out, or he'll send the packet somewhere and figure out who's google.com. Oh, well, google.com is 8.8.8.8 or whatever his IP address is. So now the router knows, hey, I need to get to 8.8.8.8, whoa, which happens to be the Google server. Whoa. Google server, and then from the Google server, I need to request the index.html, which is the start page. Okay, so now the router knows that, and this computer said I need to go to google.com. There's a whole DNS thing that they figure out that, oh, google.com is actually 8.8.8.8. So now he got a request going to 8.8.8.8, right? And he says, who is the request from? So his from is from 192.168.1.5.
But that's not routable. I think that was kind of one of the US problems.
Yes, you're right. So the only problem is that if I was to send a packet through the internet and send it to Google and say, hey Google, 192.168. Well, I need to slow down a little bit. .168.1.5 needs your index page. Google will say, well, okay, well, here's to the internet, but how many 192.168.1.5 exist in the world? A ton of them. The other thing is that you are not 192.168.5 because you only have one connection to the internet, which happens to be that guy. So the packet would never come back to you, right? So what the router does, because it has the whole NAT and PAT technology in it, is it takes your IP address and it says, all right, guy, well, I'm going to give you one of these empty ports. Okay, I'm going to give you just, I don't know, I'll pick a random one. You can just pick a session port there of 6345. Okay. So he just picked a random number there. So now he's going to grab this IP address. So now this web page is this guy right here, this 6345. So he sends the packet up. The router gets that packet. The router then says, all right, Google, I need to send the request to 8.8.8.8 from 66.11.12.13 port 6345. And that's kind of hard to read there. $63.45. So he sends it off to the world, and instead of saying that this IP address needs your index page, he's going to say, hey Google, 66.11.12.13 port 6345 is requesting the index.html. So then he's going to, Google's server is going to send you that packet, and he's going to find this IP address, which happens to be you in the whole world. Okay, because nobody has an external IP except for yourself. So once he gets it, what's the modem going to do? The modem is just the gateway, so he's just going to pass it over to the router. The router is going to grab it, and this is going to be reversed. The packet is now going to be to this guy, from this guy, and then every time I draw packets, I draw like little pills. So there's your packet there, okay? And then this has the index.html page. So now when the router gets it, he's like, oh, look, this is us. So it strips that off. And then it says, and then this is the port I need to send it to. So then he knows, oh, 6345, that is this web page exactly. So then he sends the packet down. And then your computer gets it and then loads it into that web browser. Okay? So you see how that happened? Any questions with that process of it?
So the port number is the one that machine in particular is requesting it from?
Well, who put that number there? Not the machine. The router did. The router just said, hey, you're going to be this session ID. And he just gives them a random number. He just picks a random number that's not being used by nobody.
So it's an ID under their ID?
It's just a number that's attached to their IP address. And he knows that because he's got a table within that he keeps up with all this. Because let's say on the same Internet Explorer, you open up a second tab, and that tab has msn.com. Well, the whole Internet Explorer doesn't get that one number every single session, so that msn.com is going to get a new number of 6687 or something.
That's why this port server set up here and all the signals.
Yeah. So your one computer now has multiple session addresses. One for every single web browser, one for every single tab that you've got open for just internet traffic. Okay?
With the same concept, another machine can access the internet.
Correct. And that's exactly what's going on at the exact same time over here. He's got, first of all, he's got Firefox open, and then he's got, a second tab here that has a different one, and then he's also got, Google Chrome open here, and then that's got 3 tabs on it. That's Billy right here. He's all over the internet. So each one of these gets its own number to access the internet, but every single piece of traffic through the world sees one IP address, which is your external. Okay? All at the same time. This is just web traffic. All at the same time, your emails are doing the exact same thing. The router's keeping up with which email client is requesting email, which FTP traffic you've got going on. If you've got a server that people are, and we'll talk about that in a second, remoting access or accessing remotely, he's keeping up with all that, all at the same time. Okay, so needless to say, your router is the brains of your whole network. Okay, and regardless of how many computers you've got in your local network, how many external IPs do you have? 1. Okay, and because there's 65,000 lanes from that router to the internet, you can have a lot of traffic running at once. Yes?
May I ask a dumb question? So if you have Google open and you have already assigned a port number,
Well, you don't assign it.
well, the router assigns a port number. By mistake, you close that web page, but you immediately open it again. Will you assign you another port number?
You're not that fast. What it does, when it's like, are you saying like if I open it, send a request, close it, and then open it, and he thinks it's the same one? No, you're not that fast. Even if you just click it, by the time it closes, you're still not that fast. It's incredibly fast how the router does all this. Okay, and then it keeps up because there's tons of different sessions connected directly with your web page, the tab, or the program that you're running. So even if you have multiple clients, it's still fast enough. These are nanoseconds, or even nano of the nanoseconds. I don't know how fast exactly, but it's super fast that you can't trick it and make it load from one page to the other. Okay. Usually, if there is an error, what happens is he just winds up dropping the package. If, for instance, you close the window and you open up another one, he sends the packet, and then your computer just drops it because he's like, oh, that's not open anymore. Okay? Because in this process, and I know I'm kind of dumbing it down a little bit and just talking about overview, but in this packet, the computer and the router and everybody is working together, and this number is actually very long because the computer actually does assign a portion of it, and then your router assigns another portion to it, so the number starts getting longer, and then the router just keeps up with your computer's portion, and then your computer actually delegates which program and so on and so forth. So in reality, the computer and the router are both assigning numbers to it at the same time. So it's not just like the one router's doing all the traffic. I just like to give you an overview because this is the introduction. Okay?
So, I thought I knew this, but you said all this. Where the hell's the port 80 come from?
Port 80? That's physically on the freeway, which lane it's running on.
It goes out for it.
Yeah, right here to the internet.
Oh.
Everything, all these websites have gone out this port right here. Okay, except for that this internally, he's got all these different session IDs.
On a different port it goes out to 80 because everybody's got their website set up on 80, so you gotta hit it.
That's what I thought.
Yeah. Well, see, this went out on 80, and this came in on 80 over here too.
Right.
Yeah. So it's 80 is the most used port by far, than all ports. Yes.
Here's where I get confused with all of this. Are you calling this network address translation or port address translation?
This is
Right here.
actually both.
That's what
It's called Network Address Port Translation, NAPT. And it's easily confused with one with the other. We're about to get into strictly port address translation, and we'll see the importance of that. Well, with the network address translation, you've got this going on, which is long session IDs. Okay? Not necessarily 100% related to ports. Okay? The next slide, that's 100% ports.
So with this this is your typical home
NAT.
SOHO network, obviously.
Yes.
People mistakenly always call this NAT, and it's really PAT that's going on.
This is actually NAT. The next one's PAT.
Okay.
Okay? All right. So now,
That because it's 66, 11, 12, 13 on one side, and 192, 116.
That's right.
192, 168 on
I just get confused because it's
well, it's easy to get confused because they are related, and you'll see how it is in the next slide. So let's go ahead. Any questions on the outgoing? No? All right. before we move on to the next slide, what if we had a packet coming in and, well, actually, let's go ahead and move on to the next slide, and I'll bring it up in the next slide, because now it's kind of, woo! Like, no, Jay, no. All right, so let's go to the next slide. Now we're going to talk about how does this whole system work if we need to go into our network, right? This was fine because when does those session IDs get created? When you're requesting to go out. And that's how they know how to find you, because you requested to go out, your computer put a portion, your router put a portion, now you got the session ID that the world knows how to get back to you, right? So now in this case, and this is a very common one, and I put a DVR system with cameras here because this is probably the most common for this, especially for businesses. But you can do this for your servers, you can do this for gaming even. I mean, there's tons of stuff that PAT would work for. And this is more PAT than NAT. Okay. All right. So in this scenario here, we've got an iPad over here with the 4 cameras, and they want to be able to connect from anywhere in the world through the internet to your local network and to the DVR system. Okay. Now this DVR system is a networkable. Networkable, is that a word? A networkable system that has a NIC in the back and can get an IP address and so on. It wouldn't be the analog systems that have a VCR and cameras on them. This wouldn't work for that. Okay, you'd have to get a system that is made for your network. All right. So I'm trying to figure out how to go through this. Let's start down here instead of the question. We'll bring up the question in a minute. So if this was local, and if we forgot about the top part, and this was local, and this DVR system had an IP address of 192.168.1.200, right? And this computer had an IP address of 192.168.1.100. This computer can see what's going on in the DVR with any web browser, for instance, Firefox, Chrome, Internet Explorer, excuse me, and so on, by simply opening up the browser and typing in 192.168.1.200. Okay, because jump to the router bring it back, and then he will show him that web page with all 4 cameras in there, and he can see Billy over there being a miscreant. He can see Chris over there doing his thing, and so on, and he can see everything from one web page, right? The other way these systems work is that sometimes there's a program, and that program can be by the manufacturer or it can be by somebody else. Like a good one for the Mac is it's called ASEE Plus, and this program, you type in the IP address, 192.168.1.200, and you can see all the people again, or all the cameras. So there's 2 ways you can access it, either through the program by typing in the IP address, or through a web browser and typing in the IP address. One way or the other, this system is identified by its local IP address, right? So let's go ahead and get an external IP here, because we got Time Warner this time. All right, so we've got an external IP there. Now, in the iPad, can he type this 192.168.1.200 on his program and reach it? No, why not? That's right. Because if he was to type in 192.168.1.200, he wouldn't be reaching this local network. He'd be reaching somebody else. Okay? So this right here is now incoming. Because and here's the question. If I said, hey iPad, I need you to go to 66.12.13.14, port number 8080, and I need to see my cameras. How is the router going to know who port 8080 is? What's that? Through PAT, yeah. Thanks. Well, you're not going to know because remember, in the previous one, when did those IDs come into place? When did those numbers come into place? When you were requesting out. In this case, the DVR isn't requesting to go to the iPad. It's backwards. The iPad is requesting to come into the DVR, right? So what you've got to do is set up your PAT using the router and something called port forwarding. Port forwarding. So now what you've got to do first is, can anybody guess what you've got to do? Okay, so we've got to set up the port to the cameras, right? But there's a two-step process there. One is we've got to get past this guy, because this guy, you know, as soon as you request this part gets you here and it gets you to there, but that's it, nowhere else.
Probably a firewall in there, so you got to open the port.
No, we don't have a firewall still. What's that? You've got to configure your router. That's right. And you've got to go to your router, and we're going to do that in a bit. Just in a second. I brought a little router here. This isn't my router, so I'm pretty sure it has port forward. I'm not worried about that part. So we've got to configure our router so that it knows that what? Port 8080 is .200. He needs to know that port 8080 is .200. Now, what's the other thing that we've got to set up? He needs to know that he's 200 as well. Okay? He needs to know, hey, by the way, I'm port 8080. Sorry, did I say 200? I meant 8080. He needs to know I am port 8080. So when the packet comes in, I don't just drop it. Okay? That I know that, oh, they're requesting to see my camera, so I'm going to show it to you. All right? So now that we've got this set up, on your iPad or your phone or even a computer, whether it's a program or whether it's a web browser, you can type in this IP address, put a colon, put 8080. That system's going to find your business, your home, whoever, get to the router. The router's going to get it. He's going to say port 8080. Oh, that's 200, and he's going to forward that packet over to you. And then when it gets it, it will send you the video, the live video stream. Okay. Now this is more. This is PAT and is port forwarding strictly because we are dealing with one single port instead of multiple session IDs and all that stuff. Unlike in NAT. NAT is all happening, it's called NAT overload. It's just happening all at the same time. This one, it's all traffic is going down one lane. And everybody can see it simultaneously because all that traffic is on one lane. Now these guys, they don't need to worry about the port 80s because they can just hit it directly without funneling through the default gateway up here. Let's see here. Any questions with this? No? All right. So this would also work before we actually set up the port forwarding here. This would also work if, let's say, this was a server over here, and you needed to reach your server. You can just pick a random port number, right? Let's say you want to do remote desktop or whatever kind of server you want. Whether you just need to get to a service on this computer, you would just pick a random port number, 1024 maybe, whatever, and then sign it to this computer over here, so that when you're off in the world over here and you say, oh, I need something from my desktop or I need to see something on my desktop, you know that you can type in this port 100 and reach the computer directly. And this could be confusing because the address is 100. So let's go to, oh no, that's right. I said 100, but I meant 1024. So once you assign it 100, he knows that 100 is 1024. So computer here now becomes 1024. So whenever you're off in the world, you're accessing 66.12.13.14 port 1024, and you'll go through the internet, find your router. When your router gets 1024, he will forward that packet to 100, and then it will come down, and you've reached the computer you're trying to reach from the world. Okay? Any questions there? No?
So you're going to set up the router, and how you set up the computer?
Well, it's because it depends what service you're trying to find. Like if it's remote desktop, you don't got to do nothing because remote desktop will run on the exact same port number, which I don't know what it's 1723, 3389, something like that. Well, once that packet comes in on 3389, it knows that it's looking for remote desktop. or if it was like, let's say, trying to think of what other service. If it was a mail server, then that packet will come in on 110 and it knows that it's looking for mail. The application already knows, correct. And the packet, the network traffic is bringing it on that port. So, like, if this was remote desktop, this whole thing came on port number 3389, and when he got it, he didn't need to know a port number. The router automatically forwarded to him. He sees it's on 3389. Oh, it's requesting, remote desktop, and it will pop right up. Okay.
So what about the 8080? I mean, how do you set up the DVR to be 8080?
Oh, there's settings within it, and I wonder if, my home one isn't set up. What I could do is I could bring one in. I have a bunch of DVRs, and if y'all want to, one day we can just, set it all up, and that way you can see how to set up those DVRs.
They let you change that and all that.
Yeah, they have all those settings.
Like a lot of people won't run known services on the sign ports to keep port scanners from looking for it.
Mm-hmm.
SSH. What's that?
Steve scanners can still.
Well, yeah, but, I don't know.
All right.
They are scanning for 22 years.
Here's the last thing before we set up our port forwarding on our router. This is the last piece of the whole puzzle. During this operation here, when everything's going out, everything seems to be what? Congested. Automatic. Supersonic automatic. I don't know how the song goes, but that's all I remember. All right, so it's automatic, which means your router's doing all the work. There's no extra configuration you've got to do. Unless you've got a Cisco router, you've got to set up NAT. That's about it. Once you set it up, then you're good to go. All these little Soho routers, good to go. They're set up and ready to go. Now, there's one critical piece of the puzzle, which in this case, this would be what? Uh-oh, I wrote over my Asher. Hope I don't get in trouble. All right, so this is all manual. And the last piece of the puzzle is that Verizon is still the one who assigned you this IP address, right? Well, Verizon, just like anybody in the world, and all ISPs, will every now and then have congestion or issues with their network. Very little, but they will now and then have it. Maybe once every 6 months, maybe once every 3 years, maybe once a month. It just depends. And one thing that Verizon can do is release and renew on your IP address. Which if you release and renew, what happens? It will wind up changing your IP address from 14 to, let's just say, 15. And then whenever you try to reach your network, what's going to happen? He's not going to find it. Okay, you're going to be reaching somebody else. Now, unless you pay them a certain amount of more per month, you won't have a static IP address. You're going to have a dynamic, which means that they can change it at any point in time that they want. Sometimes even if your whole block goes out, your whole power goes out, and when it all comes back up, it's just automatically will get you a new one sometimes, depending on your lease, on how they've set up their servers. So that's just one thing to be careful. If you are set up with IP addresses, then you've got to set it up or keep up in a way that if your ISP does change your IP address, that you change it on your devices over there. And if this happened, all you'd have to do was come over here and just change this 14 to what? Your new one, whatever it is. If you ever want to know what your external IP address, you can go to your router and go into status, and then we'll see where it is. Or you can just open up the internet, go to Google and type in what's my IP, and it'll tell you the very first. Don't have to hit enter or anything. Right immediately, it'll show up in the top. It'll show you what your external IP is. All right, there's a system here where it could take a DNS name and attach it to your IP address. All right. For instance, DYDNS is a free DNS service where you will sign up. Oh, DNY. This is a free service where you can sign up and you can set it up to a username and password and everything. They'll give you a username and a name, something like mynet.dydns.com, right? And then you register that in your router, and we'll see where you register that in a minute. And when you register that in your router will always forward this name to your external IP address. Whether it changes, if your external IP address changes, your router will automatically attach this to your new external IP address. Which is, a lot of people prefer that, because if your external IP address does change, you're not worried, because you're going to go to mynet.dydns.com port 8080. And when you access it, you're going to access it by mynet.dydns.com port 8080. And whether your ISP flips your external IP address or not, it doesn't matter, because you're going by the host name. All right. So that's just one of many free services that you can get in case you just never want to have that issue of, oh, my ISP changed my external IP address. You can just do that instead. All right. So any questions here? No? All right. Show and tell time. So I am going to, I think I even put a slide there. Set up port forwarding. So I'm going to grab my router here, and I'm going to unplug the internet, and I'm going to plug in the router onto this computer here. All right. So we should see, you see, oh, I got to disable. I'm going to disable my Wi-Fi here. So you see that it has a little exclamation point right down there? Oh, there's the wrong one. Come on, guy. Open network and sharing. All right, so here we're going to go to, you see that we're no longer connected to the internet. We're connected to this little router, and we've got to get into this little router. Does anybody know the best way to find what IP address he has? ipconfig. So how do I do that? Go to command prompt and type in ipconfig. And then here, this IP address right there, the default gateway, that is your router. Okay, because we said that earlier, right? All right, so my default gateway is 192.168.1.1. So let's go ahead and type that out into Internet Explorer. .168.1.1, enter. And then it requires a username and password. Let's see if we can hack it. Haha. It's admin. All right, so we're in the router here. And to kind of go over it real quick, let's take a look at these settings. And if you notice, it's broken off into sections. Here's the first section. Okay, it says Internet Setup. The next section is Network Setup. So the Internet setup would be what? My external IP. Whatever IP address my external is set up with. Whoever my ISP, whatever they gave me, I'm going to set it up right there. Now, there's different settings you can set up. There's static, PPOE, and so on. Most of the time, obtain automatically will work, just because they've all gone automatic. I remember back in the day, it was all static, and you had to enter. Wow. No wonder they gave us this router for free. Yeah. So you're supposed to set up your IP address, your subnet mask, your default gateway, your DNS, everything one by one. There it is right there. But nowadays, most of them are obtain IP automatically, so that if they've got an issue, they can just release and renew you, and your router's back up and running without calling the client like, hi, guy, I need to walk you through resetting your IP address. All right, so this is the ISP connection. So because we don't have internet here, we're not going to worry about it. Most of the time is you just call your ISP and ask them what to enter there, and they will tell you. Second. Okay. So the second part, this is your local network. Here's your IP address to your router, your subnet mask, and so on. You can set this up. We'll talk about this a little later, but this is your local network, right? What we're looking for is going to be, they have it under applications and gaming. So let's go there. All right, so now that we're in applications and gaming, we're going to pretend we've got that system, that iPad system, which is this guy right here. So we want to set up our DVR, which is number 200, to have port 8080. That's exactly what we're going to do. So over here under application, this can be anything. You can name it whatever you want. Some routers will have a drop-down list. That drop-down list could say something like telnet. It could say something like remote desktop. It can say something, so on. And the reason they have those categories is because it defaults into the correct port. All right. So if this connection that I was going to do was a remote desktop and I chose it off the drop-down list, it would fill in the correct ports for me. And those are just kind of like just easier to use routers. And in this case, we're doing it all manual, so we're just going to pick a name, whatever you want to call it. I'm going to call it DVR. DVR1 if I want to. So then the start to end. And in this case, we're not going to set a range of ports. We just want one port. Port what? 8080. Oh. Port 8080, and we're going to end with port 8080. Okay. Now, which protocol, TCP or UDP? In this case, we're just going to leave it as both. Unless your program or your application or whatever you're running specifically runs on only TCP or UDP, you would change this. If not, just leave it on both. And then lastly is which IP address do I want to forward port 8080 to? 200. Last thing I got to do, that's right, turn it on. I had somebody who forgot to turn it on. They're like, I set it up correctly. It's like, well, you forgot to turn it on. That's probably the most important one. So now that you've turned it on, just hit Save Settings. And it's going to take 5 seconds to reboot. And boom, you set up port forwarding. Okay. Now, let's go. And actually, you know what I can do? Oh, I don't have an extra. What I'm going to do, just to simulate that we have an internet service provider, I'm going to plug in the internet into my WAN port. And my internet service provider becomes Azure. So Azure is now my internet service provider. So I'm going to have an internal IP address to my Azure network, which is not going to look like a Class B or Class A or Class C external IP. It's actually going to be my internal Azure IP address. So I'm going to go to status, and let's DHCP renew. No? Don't want to? Come on, guy. You know you want to. Did I plug it in the right port? Yes, I did. It's still going up there. Well, under status, I've got two sections. I've got router and I've got local. Router being my external, my WAN, local being my internal. Okay? So internally, it just shows me what the IP address to this router is and the subnet mask, and that we do have DHCP server enabled. Okay? If I hit here, it would tell me all my clients, and in this case, I don't have any clients. Oh wait, I do. I have the computer, but the firewall is probably preventing it from showing up on this computer because Windows 7 comes with firewall pre-installed and enabled. All right, so let's go back to router and see if we have. There it is. Okay, so now we have an external IP address. Okay, and in this scenario, it's not really an external because Azure, which is another internal, is my external. But if I wanted to now access that port 8080, I could go to my internet IP address, 192.168.7.30, and then port 8080, and I would be able to reach that DVR. Okay? Any questions? No? The last thing would be probably under setup. Let's see here. Where would I set up my DYDNS once I've set it up with them? You'd go to DYDNS. It's an old one. We'll see. If you do, yeah, there it is right here. DDDNS. So, this one only has DDDNS, doesn't have DYDNS. There's different services that different routers have. The nicer ones will have all of them. And in this case, oh look, there it is, DYDNS. So once I've gone to DYDNS and set up an account with them, then I just come over here and set up the account that they gave me, and that's it. And then my router would do the rest of connecting my DYDNS account to my external IP address, whether my external IP address changes or not. All right? So let's go back to administration. No, sorry, status. So this is where you get your external IP address, and in this case, we're not really external. We're connected to our internal LAN. And then under application, and I don't know why they call it application in gaming. You have several options here: port range, port trigger, UPnP, and DMZ. And in this case, the port forwarding is the one that we were looking for to set up so that our port 8080 will funnel to our DVR system. Now the last thing to do would be on my iPad to get the program and type in this information, my external IP address and the port, or if it's a web browser, just type in the IP address, port number 8080, and it'll get me there. All right? Any questions? No? All right. Well, everybody fill out my thing. That's it. Like always, remember to fill out a lecture survey if you have a minute. Anything for me to sign?